Hello everyone, welcome to today's video. So today I'm going to showcase my project, which is a seatbelt occupation warning system. And the team members of this project are four team members: Paras, Raja, Parneet, and Prince. So the platform which we have used for this project is Tinkercad simulation, as well as embedded C we have used. And the objective of this project is that it ensures driver safety through seat belt detection. So, first of all, let me introduce this project to you. So, this project simulates a seat belt occupation warning system, a crucial feature in modern vehicles. The idea is very simple. When a person sits in the seat but does not wear the seat belt, the system should alert the person using a buzzer or LED. So this system improves road safety and can be easily implemented in real cars using simple electronics and microcontroller programming. So now let me showcase you the table, the components. Yeah, so here it is. So the first component is Arduino UNO. So the basic description of this component is that the microcontroller that runs the logic, that is the brain of the system basically. Then we have the slide switches. There are two slide switches. One is for the seat belt and the other is for the seat occupation. And the quantity is 2, as you can see. So it simply represents the seat occupation and seat belt status. Manual toggling will do. And I'll showcase you that also. Then we have DLED, which is a red LED. It is a visual warning to indicate no seat belt. Then there is a piezo buzzer. The quantity is 1. So audible alert for no seat belt when seat is occupied. So it basically does that. Then we have the oscilloscope, which is optional and it is for waveform monitoring in simulation, not used in logic. Okay. So these are all the components which I have used in this project. Okay. Now let me showcase you the diagram. Here it here it is the architecture of the project, as you can see over here. So this is the basic architecture of our project. So there are switches like switch 1, which is for seat occupation. It connects the pin 2 and it detects that if someone is sitting. Okay. And then there is switch 2, which is basically for it connects with the pin 3 and it detects if the seat belt is worn. Then there is red LED and buzzer, which are connected to pin 7. Okay. And it is via the breadboard. And then all the components share common 5V and GND from the Arduino. So when simulated in Tinkercad, these components will work together to reflect real car functionality. So this is basically the architecture sh- showcasing all these. Now let me show you the code of this project. See over here, these are the header files and it enables interrupt handling support. Okay, it provides the input output register definitions. Okay, then there are some function declarations like you can see over here. These are the functions over here, and these are custom functions defined later in the code to initialize and control the timer, the PWM, as well as the interrupts. And there is a declaration of different variables like global variables like int count. As you can see over here, these are the global variables. Okay, so the count is basically used to track the timer ticks, and the seat occupied is basically toggling, be used for toggling when seat is occupied or unoccupied. Then there is a seat belt over here. So the seat belt toggles when seat belt is worn or unworn. Then there is a request delay, which becomes 1 after delay from timer 0 to trigger buzzer. Okay, then there is an int main function. Okay, now let me showcase you this. Okay, sorry. So this is SEI, which enables the global interrupts. Okay, and there is a serial begin 9600, which starts serial communication. And then there is DDRD, D7, which sets pin D7 as output. And there is a init function, which initialize the external interrupts. Okay, now we are going to see the main loop. Okay, so this while loop is the main loop of our code. Okay, so let me explain you this. So if seat belt equals 1, okay, so this is the main logic of this code. So it simply explains if seat is occupied and seatbelt is not worn, it starts the timer 0. If the delay is over, buzzer is activated with PWM signal and message is printed. Okay, so this is the first logic. Now let me tell you the second logic, which is the else loop over here. Like over here, this is the second logic. Now let me tell you about this. So it simply explains that if seatbelt is worn, the buzzer and timers are turned off. Okay. And then there is the last logic, which is this one. Okay. So it simply explains if no one is seated, nothing should happen. Just ensure buzzer timers are off. Okay. Now, this is the init function over here. So it configures external interrupts for switches on INT0 and INT1, which is seat and belt. Okay. So this is the code for that. And then we are having PWM init function. It sets up timer 1 for TWM and compares the match interrupts trigger buzzer on off. Okay, so this is the code for that. And then we are having PWM on. So it activates the PWM with 50% duty cycle to the buzzer. And then we are having timer 0 init function. So it initializes the timer 0 for delay before turning buzzer on. And then we are having the timer off. So it disables the timer and resets delay. And then we are having PW off, as you can see over here. So it stops the buzzer by setting duty cycle to 0. Okay. So now this was all about the project code. Now let me tell you about these definitions. So this is timer 1 compare match. Okay, so it is just all about the interrupts happening in the project, like external interrupts. I have written over here also. So these are about the external interrupts. Okay, so the timer, and then we are having that the timer 0 compare matches ISR. Okay, so basically there are three cases in this project. Now I will just run this project, run the code for you, and then I will tell you about the cases side by side. So let's, so here is the project. Now I will run this project for you. Okay, so the first case is that the seat is occupied, but there is no seat belt wore by the person. Okay. So what will basically happen? The timer will run, the delay will fire, and the buzzer and LED will turn on. So let's do this. So the buzzer and LED turns on. Now let me tell you about the second case. So the second case is that the seat is occupied as well as the belt is also worn. So no warning should be displayed in this. Okay. So all off, no buzzer will run and there will be a normal operation. Okay. So as soon as the seat is occupied, the seat belt worn. So there is no buzzer. Okay. Now the case 3 is that there is no seat occupied as well as no seat belt. So all off, no warnings will be there and no action will be taken. So see, there will be no warning and no action. So these are the three cases as we have seen. So now let me conclude this project. So this project is a seatbelt occupation warning system aimed at improving vehicle safety using Arduino UNO. It uses two slide switches to simulate person occupying the seat belt being worn. So based on the logic, if someone sits and doesn't wear the seatbelt, a buzzer sounds with LED after a short delay. If seat is empty or seat, no alarm triggers. So this project is practical, lightweight, and simulates real-world car safety systems using simple hardware. It teaches how embedded systems use sensors, interrupts, and PWM to control outputs based on logical conditions. So thank you. That was all for this video.